Anybody, anything, questions on that proof? Okay, one more for today, and then this is going to be the last one, and I think we're probably going to end early. So I think I'm going to put you into breakout rooms for this one, but I need to do a little bit of notation first of all. So you guys are familiar with summations, right? We've done summations up to this point, no big deal. There's also product notation. So here's product notation. Summation notation uses a capital sigma, right? Greek letter capital sigma. That's because, it probably isn't because of this, but summation and sigma start with the same letter. So product notation is going to use a capital pi. So product notation is a pi. We can do I equals 1 to n. That's my product notation. And I'm just gonna put a function f of I here. You can have anything in here that you want. What this is multiplying everything with your different values of I. So this is f of 1 times f of 2 times f of 3 times a bunch of dots times f of n. It's product notation instead of summation notation. Summation notation just means add everything up. Product notation just means multiply everything together. All right, so for example, here's the one that we are doing in this next proof. Here's my product notation. Product as I goes from 2 to n of 1 minus 1 over I squared. That's the product notation that I'm going to use in my next proof. Product as I goes from 2 to n, 1 minus 1 over I squared. So notice that I'm starting at 2. Up here I started at 1. Down here I'm starting at 2. Doesn't really matter. You can start anywhere you want. So this is going to be 1 minus 1 over 2 squared times, product notation, 1 minus 1 over 3 squared. We'll write one more out. Times 1 minus 1 over 4 squared times a bunch of dots. And then the place that I end is my top value, which is n. So times 1 minus 1 over n squared. Good with product notation? Just like summation notation, except you're multiplying together. Give me a thumbs up. Good with product notation? Making sense there? Okay, all right, cool. Okay, so let's do one more induction proof. I'm gonna get a new slide because otherwise I'm not gonna fit all this on here. For example, prove for all n living in the natural numbers that same product that I had before, pi as I goes from 2 to n of 1 minus 1 over I squared. What I want to prove is that is equal to n plus 1 over 2n. And I've got something that I need to change, so you're going to have to erase something at the beginning. Prove for all n greater than or equal to 2. So not all n living in the integers, but all n greater than or equal to 2. Okay, careful. What's your base case this time? We'll do the base case together, and then I'll do breakout rooms for the induction step. Fingers, what value of n is your base case? Hold up fingers for me. Careful, careful. 2. Thank you. Base case is n equals 2. So here, I need to show that the product as I goes from 2 to 2 of 1 over 1 minus I squared is 2 plus 1 over 2 times 2. Base case isn't 1 this time. That's okay. You can start anywhere you want. You just got to make sure your base case is right. I starts at 2 and ends at 2, so it only has one piece that I am multiplying together on the left side of the equation. So we can say, or just to write out what this looks like, 1 minus 1 over 2 squared is equal to 2 plus 1 over 2 times 2. So that's my need to show. Just one piece that I'm multiplying together on the left-hand side of the equation. So we've just got 1 minus 1 over 2 squared is equal to 2 plus 1 over 2 times 2. Either side. You can start on either side. I'm going to start on the left side, but you can start on either side. Go ahead, write this out. This is just arithmetic. I will write it too, and then I'll put you in breakout rooms for the induction step. So do we know that? Okay, so you should get 3/4, and then I can write 3/4 as 2 plus 1 over 2 times 2. Good? Give me a thumbs up here. Everybody good on that one? Yes, good, happy. Okay, induction step. I am going to put you in breakout rooms. We'll do breakout rooms randomly today. So induction step, talk to each other, do some dictating of math. And again, this is exactly the same as the summations. You're just multiplying stuff together instead of adding stuff together. So I'll put you in breakout rooms. I'm gonna stay here for a minute and write out the answer on the whiteboard so that you can go back to the recording and see it if you want to. And then I'll pop into breakout rooms and see how things are going. So we'll do 2 rooms with 3 of you, and we're just doing random. All right, they should be open. You should have a breakout room invite. Go ahead, join, talk to each other.